Welcome to Construction Math. Today's topic is solving systems of equations by the substitution method. So on your note taker, you're going to write the definition of the term substitute. Think about it for a second, write it down, and then compare with your partner. Teacher, pause the video and call on non-volunteers to share. I'll meet you back here soon. Welcome back. Here are two possible answers. A substitute is a person or thing that acts or serves in place of another. Like when the teacher is absent, they often hire a substitute. And in a verb form it's used to add in place of. So it just means to replace. Like in a recipe, if it calls for sour cream, I can look up and find out that maybe I could use plain yogurt as a substitute or a replacement. All right, so on your note taker, fill in the missing words of the objectives. Step number one, or objective number one, is to explain the steps in solving a system of equations by substitution. Objective number two is to learn to solve a system of equations by substitution. And three is to solve a real-world construction problem by substitution. So pause the video until students have had a chance to add those to their note taker. Welcome back. Let's do a math check. All right, I want you to substitute into the following three expressions and use when A is equal to -3 and B is equal to +5. Teacher, pause the video, have students work the three problems on their note taker, and then compare with their partner, and I'll meet you back here in a minute. Welcome back. Let's go to our slate and let's look at this. The first one says we want to take 4A plus B. All right, and it said A was -3. We've got to find the values to substitute in, and B was going to be +5. So every time I see an A, I'm going to replace it by -3. Every time I see a B, I'm going to replace it or substitute it with 5. So here we go, 4 times -3 plus 5. Remember, in order of operations, we multiply first, so 4 times -3 is -12. Now plus 5, and I got the answer of -7. Second problem said to take the -A minus B. Again, I'm going to substitute in for A, and I'm going to replace it by -3. I'm going to substitute in for B and replace it by +5. Well, the opposite of a negative is a +3, or a negative times a negative is positive. -5 gives me -2. All right, the third problem said 5 times the quantity A plus B. So it's going to be 5 times -3 plus 5. Again, in order of operations, you do what's in parentheses first. -3 plus 5 is +2, which gives me +10. So take a second and check your answers and make sure you got them correct. Welcome back. Let's clear this off and go back to our PowerPoint. And let's check. Oh, good. I got the correct answers. That makes me feel very happy. So here's a problem. Foreman Al has twice as many roofing repair jobs as Foreman Bob. The cost of each of Al's repairs was $200, and the cost for each of Bob's repairs was $100. The combined cost of all the repairs was $500,000. How many roofing repairs did each foreman make? So by the end of this lesson, you're going to learn how to solve this by the substitution method. On these problems and on your test and on your final, you must do it by the method that it's described in the problem. So today you can only use the substitution method, not graphing. All right, so let's go on. So we're going to first identify the important information. All right, so look at that problem that we just did and underline the important information. Teacher, pause the video until students have underlined the important information. Welcome back. Here's what I thought was important. Al has twice as many as Bob. Cost of each of Al's was $200. Cost for Bob's was $100. The combined cost was $500,000. And the question asks us how many of the roofing repairs did each foreman make, and we're going to make sure that by the end of this lesson we have solved this problem. Now the steps, very similar to the steps for graphing, and in the following lesson we're going to learn about addition method, and same thing. You identify the important information, define the two variables, write two equations, and select a method to solve. Today's method to solve will be substitution. So again, here are the three methods. In the previous lesson, we did graphing. We're now doing substitution. And in the next lesson, we're either going to do elimination or addition. And no matter what method you use, you'll get the same answer. And always remember to write your answer as an ordered pair. It matters which one is X and which one is Y, and label each one if it comes from a real world problem. So the steps in substitution. All right. So anything in red, you're going to fill in your note taker. So it says solve one of the equations for either of the variables. That's your choice. And I'm going to give you some suggestions that'll make you a better choice, but it's your choice. Number 2, substitute that expression into the other equation. It's important it goes into the other one because you've used the first one and now you're going to put it into the second. 3, solve the equation. And then 4, substitute into either equation and substitute for the remaining variable. So those are the steps, and we'll go through with several examples in here. All right, so paraphrase, summarize the steps in your own words. All right, so make sure that you can understand what those steps mean. Pause the video, teacher call on non-volunteers. Welcome back. So here's an example. I want you to figure out what two numbers add to 6, and when you subtract them, they equal to 4. So find the two numbers, just think about it. Just do a little guess and check. Share the answer with your partner, and then teacher call on non-volunteers. Welcome back. I found the answers were 5 and 1, because 5 plus 1 is 6. 5 minus 1 is 4. And so in this example, we're going to remind you of how to use the substitution method. So we're going to solve this equation. So let's go ahead and go to our slate. And let's go ahead and look at this. All right, I know two numbers are going to add together. Oops. Let's go ahead and say, let's let X equal the first number. I already know what the answer is going to be, 5 and 1. And if I don't get it, then I know I'm in trouble. So the first number, and Y is going to be the second number. Here we go. It said the sum of the two numbers was 6. So X plus Y equals 6. The difference of the two numbers is 4. X minus Y equals 4. Because remember, difference means subtraction. Now, I have to solve it for one of the variables. That's the step that it told me to do first. And I have 4 really good choices. I can solve it for X in the first one, Y in the first one, X in the second one, Y in the second one. What I always look for personally is I always look for any variable who has coefficient of 1, because that's going to cut down on the fractions. So let's just take the first equation and let's solve it for X. All right, I'm going to get X all by itself. So the inverse of adding Y is subtracting Y. So I'm going to get X equals negative Y plus 6. I used the first equation once. I won't use it again. And I like to cross it out so I don't remember. Now, what I'm going to do in the second equation is wherever I see an X, I'm going to replace it by negative Y plus 6. So let's get started. Here's the equation X. I'm going to replace that by negative Y plus 6. Then remember to continue copying that equation till you get every part. Now I've got one equation and only one variable. So if I add the like terms, negative Y and negative Y give me negative 2Y plus 6 equals 4. The inverse of adding 6 is subtracting 6. So I get negative 2Y equals negative 2. To get the Y all by itself, the inverse of multiplying by negative 2 is dividing by negative 2. So I get Y equals positive 1. So remember in the ordered pairs, this one is X, this one is Y. So I put the Y right there. Now I'm going to substitute it in here and find out what X is. So X equals the opposite of 1, which gives me negative 1 plus 6. So X equals 5. And there's my answer. That's exactly what we guessed it would be. Now, I can do this problem and solve it for any of these other ones and still get the same answer. So it's your choice, and when I grade your test, I'll have to be very careful to watch the steps you use. All right, so let's go ahead and pause the video if you need to. Welcome back. Let's go back to our PowerPoint, and let's see. There was the question. X is the first number, Y was the second. I selected, here's the steps. I decided to solve for X in the first equation. I got Y equals 1. I substituted, got X equals 1. I put the answer in XY form. So here's one that you get to try. You try it. My suggestion for you is to, I'll give you two choices. One, you can solve for the Y in the top and you won't have fractions. Or you can solve the Y on the second equation and you still won't have fractions. But just for consistency, let's all solve for the Y in the first equation. Teacher, pause the video until everybody's had a chance to finish it and compare with their partners, and I'll meet you back here in a minute. All right. So let's go ahead and go to our slates. We decided 2x plus, oops, I got a little too high. 2x plus y equals 14. And we got 4x minus 2y equals to negative 12. All right, so I'm going to solve for the y in the first equation. So I get 2x plus y equals 14. Subtract 2x from both sides. So I get y equals negative 2x plus 14. I've used the first equation. I don't want to use it again. So now I'm going to substitute it in the second equation. It goes 4x minus 2. Oh, there's the y. That's where I put in what y is equal to. Y is equal to negative 2x plus 14. And that, remember to copy the whole thing, equals to negative 12. So I get 4x, distribute. Negative 2 times negative 2x gives me positive 4x. Negative 2 times positive 14 gives me negative 28. Equals negative 12. 4x and 4x give me 8x. Subtract 28 equals negative 12. We're going to add 28 to both sides. Let me continue over here. So 8x equals, if I do the math right, 16. Divide both sides by 8, so x is equal to 2. All right. Let's see if we did that. And we're going to plug it back in where I found what y equals. I like to plug it back in here because it's a little simpler math. Y equals negative 2 times the value of x, which is 2, plus 14. Negative 4 plus 14 gives me 10. So my answer is going to be x equals 2, y equals 10. And let me double check. And I think that looks pretty good. And there's my answer. All right, so pause the video, and then I'm going to come back and show you how to do it if I solve for the y in the bottom. Welcome back. Let's solve for the y in the bottom. Let me get the problem down again. We have 2x plus y equals to 14. I have 4x minus 2y equals to negative 12. And I'm going to solve for this y this time, just to show you that it works. I'm going to copy it down and solve for y. Oops, put the equal sign in. Subtract 4x from both sides. So I get negative 2y equals negative 4x minus 12. Divide everybody by negative 2. So I get y equals negative 4 divided by negative 2 is positive 2. Negative 6 divided by negative 2 is positive 6. So I've used this equation once. I'm not going to use it again. So here we go. 2x plus y. Well, y is 2x plus 6 equals to 14. Add the like terms. 2x plus 2x is 4x plus 6 equals 14. Subtract 6 from both sides because the opposite of, or the inverse of adding 6 is subtracting 6. So 4x equals 8. Divide by 4 and I get x equals 2. Oh, I think that was the answer the last time I worked it. If I put it back in down here, whoops, right down here, y equals 2 times 2 plus 6. 2 times 2 is 4, plus 6 is 10. I got exactly the same answer. So you can see that no matter which one you solve for, that you should be able to be fine if you don't make an arithmetic mistake. Now, you can always check your answers, especially if this is on a high stakes test. If I want to go ahead and substitute in, remember this guy's going to be x and this guy's going to be y. So I'm going to put them in the original equation. Is 2 times 2 plus 10 equal to 14? 2 times 2 is 4 plus 10 is 14. That checks. Put it into the second one. 4 times 2 minus 2 times 10. Does that equal to negative 12? Is 8 minus 20 equal to negative 12? Yes, it is. It checks. So if you want to check, it's perfectly okay. I'm not going to require you to check, but it'll be fine. So pause the video until students have had a chance to complete adding these to your notes, and I'll meet you back here in a minute. Welcome back. Let's go back to our PowerPoint, and we'll just kind of skip through these because I had you already work that. Did you get the right answer? Now, here's the think, pair, share. I want you to work with your partner and decide, how do you think you're going to decide if you're just given a problem between the graphing method and the substitution method? Which one should you use? And then I'll meet you back here in a minute. Teacher call on non-volunteers. Welcome back. Here's what I think. If it's going to be substitution, when it's easy to use substitution, then it's when you can get a coefficient of 1 for either variable in either equation. Also, if the numbers are relatively small, if you're not afraid of fractions, substitution is an easy method. With graphing, if you have an idea that the solution are going to be small and be integers, so that your answer comes out to be on a corner or a vertex of where the x and y axis meet, I would use graphing. If I'm not sure, I probably would stick with substitution, because if the answer is very small, it's going to be really hard to tell if your answer was 1/10, 1/15. I don't think I could read that off a graph. Or if the numbers were going to be rather large, like 200, 500, I don't want to have to make a graph that big. So graphing is a fun method. It's certainly usable, but unless I was sure, I would probably use substitution. So here's our problem again that we've underlined in the original problem that I gave you. And so let's see if you can solve this one. All right. So teacher, pause the video, give the students a chance to work it. If they can only get step 1 where they pick the variables, fine. If they get step 2 and they can actually substitute in the equations they got for step 1, that's great. If they can solve it, super. And if they can solve for the second one, just see how far they get. All right, let's pause it. You can call on non-volunteers, and I'll meet you back here in a minute. Let's get to our slate. All right, and as first of all, I'm going to pick x and y, and I keep hitting that. So x is going to equal Al's repairs. They're going to be in dollars, but that's okay. And let's let y equal Bob's repairs. So on the test, if you can only pick out what x and y are, you'll at least get a point. So it said in the problem, let me go back and read it exactly. It said that Al, well, Al is x, and of course you could have used A and B if you would have wanted to, has twice as many as Bob. So Al equals twice Bob, and Bob is y. There's our first equation. Our second equation said that Al made $200 per repair. Bob made $100 for repair, and it was up to $500,000 was the total. So if this was all the farther you got, let's see, teacher, pause the video and have the students solve it. If they've gotten farther, continue running the video. All right, this one's really nice to solve by substitution because it's already solved for x. Every time I see an x, I'm going to replace it by 2y. So I get 200 times 2y, keep copying the rest of the equation, equals 500,000. So 200 times 2 is 400y plus 100y equals 500,000. 400y and 100y gives me 500y equals 500,000. Divide both sides by 500. And I learned that when there's zeros at the end, I can cancel them out. so I don't have too much work to do. And then 5 divided by 5 is 1, so y equals, and I know it's money, so it'll be $1,000, or 1,000, I'm sorry, I don't think it's money, I think it's number of repairs. So let me just double check. Let's take off the dollar sign. So Al's group made 1,000 repairs. Substitute it back in. X equals 2 times 1,000, which would give me 2,000. So Al's people made 2,000 repairs. So if you used A and B, that's perfectly fine also. All right. Pause the video if you need more time to study the solution. You could have solved for X or Y in the bottom one, but this one just looked a little cleaner to me. Welcome back. Let's go back to our PowerPoint. And here we go. Solved it. Substituted. There we go. There's my answer. So now you try this one. A piece of PVC is 30 inches long and cut into 2 pieces, with one part being 4 times the length of the other. How long is each piece? So work with your partner and solve the problem, and I'll meet you back here in a minute. Welcome back. Let's go to our slate. Let's let X equal the smaller piece of PVC. We can let Y equal the larger piece. And let's see what we come up with our equations. Okay, it said the total length of the pipe was 30. So X plus Y is going to equal to 30. That's your first equation. It said the longer piece is 4 times as long as the smaller piece. So if this guy was like, the smaller guy was 3, this guy would be 12. So the longer piece is Y, is 4 times the smaller piece. Oh, look, this one's already solved for Y, so I'm going to use that. So I get X plus Y is 4X equals to 30. 4X and X is 5X. The inverse of multiplying by 5 is dividing by 5. So X equals 6, and let me get the right units. It was inches. So the small piece, it was cut into 6 inches because we're going to ignore that there's waste when we cut. Then Y equals 4 times 6 inches. So the longer piece is 24 inches. And it makes sense. They add up to 60 inches, and the bigger piece is 4 times the smaller piece. Nice job. All right, let's clear that out. And let's go back to our PowerPoint. There, we worked it out perfectly. And here's your 12-word closure. What was the most important thing you learned about solving systems of equations by substitution? And if you want to compare it to graphing, why you would pick it over graphing, that's perfectly fine. And I'll meet you back here another time for another construction math lesson.